All right, everybody. Thanks for joining. Looks like we've got some people piling in here, so we'll go ahead and get started. This is a new training, so we never know how long it's going to take. So we'll jump right in and might maybe repeat a few things if more people join. All right. So I've got some. I think I got my video on here. Matthew, can you see me? Okay.
Yep, looks good.
Awesome. Okay. Well, today we're going to be talking about. Well, I guess first, my name's Troy Daniels. I'm the head of technical training here. We also have Matt Walker with us. He is also a technical trainer here at Simplify Power. So we're going to be kind of passing back and forth talking about this subject. It's something we really haven't kind of jumped in too deep in the past. So, we've always kind of briefly touched on the surface when it comes to battery management systems and really our own battery management system, but we're going to talk today a little bit more general terms about what battery management systems are, what they do, and then kind of go into what we have to offer as Simplify Power. And we offer really different types of battery management systems based on product and kind of discuss why one makes more sense than the other. So we're going to jump right into that. We're going to start just with a very brief, let me get my slides working here. There we go. We're going to start with just our basic company overview and history for those that maybe don't know too much about us. For those that have already heard this a bunch, just bear with us and we'll get to the kind of the bulk of the presentation. One more housekeeping item before I get started. Q&A. If you've got any questions, there is a Q&A little tab there. If you go up to your control bar, you can type in questions right there. And we will spend some time at the end answering any questions. I see a hand raised. Sadly, we can't do anything with that. So just type any questions as you feel into the Q&A, and we'll get to all those at the end. Okay, so a little bit about Simplify Power as a company. We were actually founded in 2010 as OES Energy. At the time, we were really looking to solve a problem that we saw as a problem. And that would be how to find a clean, reliable battery to replace the current batteries that were being used. And those might have been anywhere from lead acid batteries or to current lithium batteries that were in use that typically contain cobalt, which is really the main driver of thermal runaway and what we see as unsafe lithium batteries. Where we kind of landed is to find lithium iron phosphate as our chemistry. And lithium iron phosphate we found to be a lithium chemistry that was safe and very reliable, had high energy density, high power output, really everything we wanted in a battery. So in 2011, 2012, with the military, the Department of Defense actually, we worked with them and were approached to look at implementing our battery technology into lead acid replacements and look at diesel offset. Now, at the time, the really interesting thing here is that the military was actually saying, we don't want lithium batteries in these systems. We are saying no lithium batteries at all on this project. We're talking about high temperatures in the desert, as well as the stigma around lithium batteries having this thermal runaway, catching fire, being dangerous. We were able to make our case for lithium iron phosphate, saying that it is not prone to thermal runaway, that it is a safe technology. And we were actually able to implement our batteries into this project. And not just that, but we were able to prove our technology through some very harsh testing conditions and validations with the Department of Defense, and show that lithium iron phosphate is not just reliable and a great use for these lead acid replacements, but it is also safe, even in the harshest conditions. From there, 2013 to 2014, we did start to focus a lot on expanding our product line as well. ESS, energy storage solutions, all-in-one products, more integrated solutions as well, really trying to provide that kind of easy solution for installers and customers alike. We've really always had throughout the years a focus on, I'll say this at the very last here, but we do have a change. We are adding products that might go against this, but we have always kind of focused on distributed assets. Looking at power at the, a customer having a storage solution that's a distributed asset. It creates a more resilient grid, and we'll talk about that coming up here. But it also, kind of gives the customer more power to themselves. And I don't mean that in a literal way, but taking back their PV and things like that. I think a lot of customers, even at the time, and especially in 2015, 2016, might not even been aware, and still to this day, it's probably the case, that when the grid goes down, they lose solar power. And they're just selling back whatever they have that's not being used during the normal operation of the grid. And we were looking at, distributed assets as a way for the customer to take back that power that they're generating and store it and use it and make sure they have their own kind of reliable mini grid when the power goes out. Since then, up till now, we've really been, and I guess I got to change that slide. It looks like I got to change that to 21 now officially. We have been ramping up production, driving down cost of our batteries so that we can pass that along to installers, customers alike. We've moved into a larger facility where we manufacture, and we have even come out with products like the high voltage product, which is for even commercial and industrial use. So while not necessarily specifically a distributed asset, we are kind of looking at it as the big picture, but really looking at products as we can expand to meet any need that might come about. Okay, I want to talk a little bit about UL listings. I think it's important to talk about. As far as our UL listings that we look at here, the main one, 1642, and probably not super relevant to anybody that's working with our products. 1973, a battery level, that is very important, definitely a big standard. And now 9540, which is system level, which is going to become more and more common. This is related to also, I think the big confusion, I even have troubles with myself, 9540A, which is separate. 9540A is the test protocol, not a certification. 9540A or 9540, we do have on some of our all-in-one products, like our SolarArc Access. That is the system level requirement of that UL listing. So we do keep up on our UL standards, make sure that we're always keeping an eye on what's new, what's upcoming. Keep our batteries current on that standard. Application-wise, just some ones I like to mention. We're talking about distributed assets, talking about customers taking back their power production, and what are some things that I'm seeing people use more and more when it comes to specifically, I guess, grid-tied systems or hybrid systems. Peak shaving, I see this more on the commercial side of things, but definitely, looking at those 15-minute peak intervals and how to cut that out with a battery. Time of use, this one is just going to keep going bigger and bigger. I can't see this going away. I just see more utility companies charging that demand during those peak hours. So, maybe 5 to 7 or whatever, when people are getting home from work, or at least used to get home from work. It's changed a little bit now, but charging more, and a battery and our products and even our ESS products can really mitigate that factor and cut out that time of use rate. So that's going to be more and more of a sell, and why it makes sense to add up storage, especially just adding storage when you've already got a PV system in place. Integrated solar plus storage. I mean, we're going to talk about other sort of production methods such as wind and grid and things like that and other trainings, but integrated solar plus storage is still the biggest use of what we're talking about, and looking at even adding a storage solution to an already existing PV system. So again, just to reiterate the fact, we are talking about our batteries being lithium iron phosphate. This is our lithium chemistry we choose. Just to be more specific, we use a cylindrical form factor. We are constantly testing different types of cells and making sure that what we use is the highest standard and above the other ones as well, as far as resiliency, efficiency, longevity, something we can really stand behind. Okay, with that, well, I'm having trouble advancing slides. Okay, I am going to go ahead and pass it off here in 1 second to Matt Walker, and he's going to take us into what is a battery management system.
All right. Hopefully that control works. Thanks for that intro, Troy. So let's jump into what is a battery management system. And to start, if the slide will advance. Awesome. So a battery management system is often referred to as the brain of a battery. It's really going to manage the operating parameters of the battery to an extent. It's going to monitor environmental conditions and maybe even take data. And another main function is it's going to balance the cells. I even like to think of the BMS as the lifeguard of the battery, more so than the brain, because if you're in the pool and you swim outside of the area you're supposed to swim, the lifeguard's just going to tell you to get out of the pool. And it's the same with the BMS. If the power coming into the battery, if you know the BMS senses something is not right, it's just going to open circuit and not accept that power. That is really the main function of the BMS. So it's going to protect the battery from damage, and then through cell balancing, it's going to ensure that the battery has access to its full capacity every cycle. So why do you need a battery management system, or do you even need one at all? Technically, any battery can actually function without a BMS. It just doesn't mean it's going to function very well. Like, for example, lead acid batteries, they generally don't contain a BMS. They could benefit from one performance-wise, but when you weigh, you know, the cost of the BMS versus the benefits you're getting, it just generally isn't seen as worth it in most cases. You know, additionally, lithium batteries have a slightly wider voltage range, so this allows more cell balancing to just occur naturally. However, in lithium batteries, a BMS is, you know, very much more necessary. It's, for example, in batteries like NMC batteries, it's entirely necessary to have a BMS to prevent thermal runaway, as, you know, simple overcharging event could easily cause some sort of catastrophe. And with lithium iron phosphate, again, it does add safety, but main functions are just to prevent the battery from being damaged and ensure the full capacity is available for each cycle instead of being limited by the weakest cell. So let's talk about that a little bit more. First, it's important to understand, you know, what the BMS is going to look like inside the battery, as in where it's going to be placed. This, I want to be clear, this is not our battery. This is just a general diagram, but it's an example of where you can place a BMS inside your battery. So this is a 12-volt system here, just a 4S for 4 cells. And so it's going to show that the BMS kind of interrupts the negative end of the circuit. Some BMSs do have a cell temperature probe. As you can see here, this one does. Some do not. And BMSs are going to use contactors or FETs to open and close the circuit. So for the purposes of this training, I don't want to dive in too deep to what is a contactor or a FET and how does it work. I just want to mention, you know, those are basically a switch. They're just going to open and close the circuit. And I think a question we get a lot here at Simplify is like, why can't I just charge my battery from anything? I should be able to plug my 48-volt battery into the car alternator, into the wall outlet, into the charge controller, and it should just take all the same. Unfortunately, you know, that's just not how a BMS works, and it's not what it's designed to do. A BMS does not like modify the power that you're giving it. It's not going to throttle the current, and it's not going to modify the voltage either. It's just going to accept or deny that power by opening or closing the circuit. So what types of battery management systems are out there? There's many different types. Let's see if we can kind of get a general overview here. Analog BMS, this is kind of the original BMS right here. It's programmed, if at all, during manufacturing. Many of them don't need programming at all. It's made up of just simple hardware components that are very reliable, tried and true, like FETs, resistors, and diodes. Its performance is based on electrical signals like voltage. So if a voltage across a certain component reaches above a certain amount, then it's going to allow current to flow, et cetera, and action is taken. And really, the action being taken is usually just opening or closing the circuit. So again, this relies on the electrical values. It does not rely on, digital signals like, the user inputting a certain voltage, like a high voltage limit or a low voltage limit. In this case, those limits are just set by the physical constraints of the components on the board. Then the digital BMS is kind of the newer type of BMS. It's got generally, it usually has a user interface. It doesn't, it doesn't need to have a user interface, but most of them do. They are programmed. They have some sort of controller or processing unit. So they're at least definitely programmed, during manufacturing to tell that controlling unit how to work, how to function, and they may even be reprogrammable in the field, through whatever software, whatever user interface you have. These are going to take digital inputs, like if you input 58 volts as your high voltage limit, it can execute a disconnect when 58 volts is reached instead of relying on the value across a certain component. It can sometimes have the ability to transmit data. Some digital BMSs do not transmit any data, but most of them do collect and transmit data to external equipment. And again, just wanted to point out that batteries with a digital BMS, that does not mean they don't also have an analog BMS. They could have both. So for example, you could set your digital BMS to execute a high voltage disconnect at 58 volts. And you may even have an analog BMS back there as a failsafe to execute a high voltage disconnect at 60 volts in case the digital BMS for whatever reason fails. And again, just want to remind everybody that I'm really speaking in generalities here. This is, Troy's going to talk a little bit later about the BMS, the battery management systems that are in our products specifically, and the differences between those and which is right for your project. This is just kind of a general overview of what's out there and how it works. For example, there's low voltage and high voltage BMSs. So a low voltage battery management system is not designed to be put in series. This is, for example, our 48 volt series, the 3.8 kilowatt hour 5 battery, the Amplify battery. They're parallel connections. The reason for this is because too much voltage could damage any one battery. So if a BMS, let's say you have two batteries in series, right? You have two 48 volt batteries to make a 96 volt circuit. Let's say one of those batteries is becoming too full and the BMS opens the circuit so it doesn't charge any further. Now, we still have one battery with a closed circuit in the BMS. So now the battery with the open circuit is going to be exposed to the full voltage of the 96 volt stack. And it's going to be, that voltage is going to be applied right where the open circuit is. So if that's a FET or a contactor, like we said, opening the circuit, If it's not designed to handle that 96 volts, it's going to be damaged. High voltage are obviously a bit different. They're designed for a series connection, and whatever's opening that circuit, the hardware is designed to handle the full stack voltage. Additionally, within a high voltage stack, each individual battery does not have a single BMS per battery, but each battery is going to have basically a cell measuring and balancing device. And this device might also read temperatures. It may or may not read temperatures. So why are the different types of battery management systems, why are they so important? A major reason that they're so important is cell balancing, and they're also going to provide a lot of protection. So first, let's jump into cell balancing and the different types of cell balancing there are. The main types are passive and active. So here's kind of an overview of passive cell balancing. It's basically going to, let's say you have a 4S 12-volt battery here, just for an example, and one of the cells begins to get full before the other cells are full. So what's going to happen is while the rest of the battery is charging, the BMS is going to kind of force this cell to dissipate some of the excess energy as heat, so it doesn't get too far overcharged while the other cells continue to charge. So of course you're a little limited here. You're dissipating power inside the battery, so it's very small in scale to keep the battery from heating up too much. But generally, with new cells and with high quality cells, this is really all you're going to need. It balances the cells at the top of each charge cycle. And again, brand new high quality cells, they're going to come already quite balanced. So there's not a need for much further balancing. Here's another type of balancing that active cell balancing is going to be a lot better, and maybe even totally necessary for second life cells that have a larger difference in remaining capacity. So if you're buying used e-bike cells and building a custom battery or something along those lines, this is what you're going to want here. This is going to actively pull power from one cell to charge another cell, or even just to charge the battery as a whole. Both passive and active cell balancing are driven by voltage differences between cells. However, active balancing is definitely going to be a larger scale than passive balancing. This is just a ballpark range, but definitely a larger scale in general than passive balancing. And this diagram here, shows basically one battery charging up a capacitor, and then that capacitor is going to switch and discharge, effectively charging one of the other cells or the battery as a whole. This really isn't that practical. It wouldn't work all that well. It's just simple diagrams, kind of oversimplified so that we can all understand it a bit better on a base level. But that's not how it would really work in practice. So cell balancing and protection. Let's now talk about closed loop digital BMS versus an internal analog BMS. An internal analog BMS is just going to work on its own, right? So it's executing actions based on the values on the physical components on the board. It does not work with other equipment or communicate externally. And this is really there to prevent disaster and balance cells, but it's not designed to be the only line of protection. Again, you don't want to plug your battery into the wall with no charger. It's not working. It's not going to work like that. Neither is the closed loop digital BMS, but one advantage here in the closed loop BMS is that it's able to actually communicate with the inverter as well as work independently. So the BMS is going to communicate to the inverter what it wants to be charged at in voltage and current values, and it's going to ask the charger to meet those. The same with the load. It's basically going to nicely ask the inverter to, hey, please limit the load to this value. This is all I can provide you. And hopefully the inverter will obey that. And then additionally, it's going to most of the time collect and report data, which is a huge advantage when you're troubleshooting a system, for example. So now I'm going to hand it back off to Troy, and Troy can talk about programming as well as how, the
Oh, looks like Matt got muted there. Not sure why. It might have been my bad. All right, so just gonna wrap it up with some programming, and we are talking a little bit more in terms of the simplified products here, and then we're gonna end with a little bit about the products and choosing products, and then we'll wrap up with questions. I see some questions coming through already, so just keep shooting any of those questions that you have in. We're happy to answer them at the end. Okay, programming. So Matt just kind of touched on a little bit there, regarding programming and this kind of idea of, hey, I thought this battery had a battery management system. I plugged it into the wall. We're good to go. Not true oftentimes. It is true for some of our products, can do a little bit more. So let's start with the ones that don't. Now, when we're talking about internal analog BMS, so that, we just kind of went through what that means, but, our 5 battery products does have that internal analog battery management system. And when it comes to that, the programming is done externally on external equipment. That is the main source of protection when using the standard 5 products. And the BMS alone does not provide the warranted protection. It cannot just say, hey, I don't want to discharge past this point. That's really still relied upon on the programming as you would with other batteries. So, looking here at the system control panel, the Schneider system control panel, great example. That is your key to programming these batteries. The battery management function in these batteries does have protection built into it, but it's really not what we rely upon to uphold the warranty of the battery. It is also important to consider the sizing, the minimum sizing requirements. If you've taken any of my other trainings, you know all about the system requirements, the sizing requirements, the 2-to-1 ratio. If you've got 8 kilowatts of inverter, make sure you have 16 kilowatt hours of battery, my favorite example. Because the BMS, the internal analog BMS in these 5 products does not automatically tell the inverter to ramp down and not output more than it can handle. And also what's built in as far as protection, you can overload it pretty much. If you got an oversized system, you can definitely overload it and cause damage that's not covered. So that sizing is really important when it comes to our standard 5 products, still that analog BMS driven products. So some of the most important settings I can think of when it comes to programming a battery, one of our batteries with this BMS, is looking at programming things like the low battery cutout. How low will it possibly do you want a battery to go? For instance, if it's a 48 volt battery, 48.0 is actually the 100% depth of discharge, as low as we want to go. Charge voltage, and what I mean by that is really high end voltage. Again, the BMS is not telling the system what to do, so programming charge voltage is very important. And max charge current is really important as well. So check out our integration guides. But again, the idea to drive home as far as battery management system goes, and what we're talking about here is the battery management system with our internal analog BMS, our standard 5 products, is not doing the programming for you. You still need to do this programming on the system. Now, it is a little different with our newest battery, the Amplify battery management system. So the Amplify battery and its battery management system does have closed loop communications. So this actually can connect to the inverter. Now, it's only can do this when it's hooked up to an inverter communicates with. Currently, that's just the Solarc right now. We do have a lot more, and I apologize for the light. The sun's kind of going in and out here a little bit. We do have a few different products that are being lined up to be communicated with soon, very soon. But when it does connect to a product that it communicates with, the Amplify battery can auto-populate set points. The most crucial settings are automatically programmed. The Amplify battery can actually identify the bank size and adjust the settings accordingly. So it knows if you've got 4 batteries, if you've got 5 batteries, and it can do that programming for you. So it does do a lot of the work. It is a little bit more plug and play. Again, this is only applicable when connected to an inverter that is set up to communicate with, which is currently the Solarc. So to dig deeper into programming or products that I kind of just I was just mentioning, the Phi product, this is coming with our standard internal, or what you might call our analog BMS. Looking at this is our standard product, and I think the biggest thing I'll drive home and coming up here in a few slides is just because one battery management system does not have comms and one does not make it worse. It's looking at your application, understanding really what makes sense. There's a time and a place for both. We'll talk about that. So this does not have communication capabilities, but the good news is does not require battery-to-battery connections for proper installation and functionality. It also does not require any sort of connection to the inverter. We're just talking about battery cables, no comms cables. Definitely, if you're doing a huge system, this can save you a lot of time. They're also scalable. They don't have, as far as a limit goes, you can scale as many of these products as you want together because they don't have that limit. And the limit often is driven by that communication protocol. And a lot of the time, if you're looking at other companies, you will see that they have a limit to. I actually just saw an interesting article. I won't mention the specific name of the company. They put our battery at a limit of 30 batteries. It's a bit confusing because that's not true. Definitely not with our standard battery. We do not have a limit of 30 batteries. With this standard Phi battery, you can put up as many as you want in parallel. The Amplify, as mentioned, this is our newest addition to our product line. It is a bit different. It does have that Amplify. It does have the closed loop communication with the inverter through its battery management system. So it does things like auto-populate set points and does advanced integration. So high-level protection, high-level accuracy as far as the readings. It's actually telling the inverter what its state of charge is, where the voltage is at, what the charge and discharge is. It also can be flexibly sized. So I mentioned, I mentioned the idea of, 2-to-1 ratio with a standard Phi batteries. Not the case with this. If it's hooked up to the Solarc or another inverter that it communicates with, it can actually, you could have one of these on a 12 kW Solarc. So you could have one Amplify hooked up to a 12 kW Solarc because it can limit its discharge and it has that extra protection built in. It is that digital BMS and does have that closed loop communication. It's set up properly to do that. It is limited. I'm going to shoot myself in the foot here because I actually can't remember the limit. This is where I think the confusion came from in that article I saw. This one does have a limit. I believe it's 40 currently. It's either 30 or 40. I apologize. It's spaced 40. My mind. Sorry, go ahead, Matt. 30?
It's 40.
40.
You're
yeah,
right.
I think it was 30 and now it's 40. And it's going to keep going up. But 40 batteries in parallel, it's still a lot, but that is the current limit on this battery. Again, standard Phi products, big advantage to them. They don't have a limit. This one does have a limit due to comms. And the last battery management system variation that we would offer in a product is looking at our high voltage products, and which is an external battery management system. What does this mean? We're talking about a stack controller. You can actually see it in this image here. Let me see if I can find my mouse. That's the stack controller there. And so each battery module is connected to the stack controller BMS in the switchgear. There's cell interface, maybe either internal or external to the module case. And you'll see that, so that it's all connected to one central stack controller there, or multiple stack controllers depending on your bank size. And this is actually has some pretty big advantages. This is a pretty advanced battery management system. I mean, you can do monitoring. I've seen the monitoring platform myself, and it's really advanced, and it's really battery kind of specific. As far as the voltage range, which is really what's dictating our voltage range on our high voltage product, is 200 to 1,180 volts DC nominal, to be very specific. Again, this would come with our high voltage products. So we're looking at things like our microgrid solutions or large scale backup, maybe 40 volt 3-phase solutions. And that's where this would come. Okay, so again, to kind of drive this home, I think the misconception is that oftentimes, oh, well, this product has comms and this one doesn't. I should go with the comms. It's just not true. I mean, there's definitely situations where it doesn't matter. And frankly, you're going to find less expensive cost when it comes to batteries without comms, definitely ours. Looking at the Phi versus the Amplify, the Phi is less expensive. So if it's not required, oftentimes it doesn't make sense. You know, all the projects are different, and I'll just read this straight. And it is often important to understand each product can benefit from a specific battery and BMS combo. So like looking at off-grid and lead acid replacements, I think the Phi product makes a lot of sense there. You know, we've worked on these programmings with, and it's not hard to program the system to interact with this battery. And definitely lead acid replacement, we might be going with older equipment anyway that might not even have the ability to set up with our comms. So it just makes more sense in that way. I will say grid tied and kind of monitoring heavy systems, so maybe a battery backup that's being added to an already existing PV array. Sometimes customers do want a little bit more monitoring and accuracy and things like that. You could probably go with either battery. We can definitely get monitoring on the standard product. It's just a little trickier. But yeah, some kind of techie people, you know, ahead of the curve type people might want to just make sure that they have the latest and greatest comms. And that might make sense to go with the Amplify. Grid interaction wise, you know, I will say it's really not necessarily even on the BMS at this point. So it might not make sense either way. You know, it might be a completely different product when we're talking about grid interaction. However, probably you'll start to see more and more grid interaction like reactive power and solutions like that that might be tied more to the communication protocol and how the battery can interact and report to the inverter. C&I projects, it's good to think about here, you know, what's the scale of the project? Maybe if it's really large, you need to go with our standard Phi product versus other competitors too that have that limit as well. Well, our Phi product doesn't have that limit. You can build a huge product without that issue. Or if it's C&I, maybe you're going to go with our high voltage product, which does have, can be scaled up really large and doesn't really have those restrictions as far as sizing goes. So the kind of the point to drive home here is, you know, it doesn't necessarily always make sense to have comms versus non-comms, and the other way around too. It's really look at, you know, what your customers' needs are, what the application is, does it make sense, and as an installer, what do you prefer oftentimes? But each battery and each BMS is really driven to fit certain needs, and I think something we really try to strive for here at Simplify is fitting, you know, getting a product that fits every need. So not just having one size fits all. You know, if we just went with comms on both of our batteries, now you have a more expensive battery. You don't have that option of the other battery, the standard Phi battery. So it's going to make a lot of sense to have both. Okay, just to kind of wrap up a little bit here, I'm going to mention our IQ program, as I mentioned during every presentation. I think it's really important to talk about. We're adding more and more people onto this program. It's definitely growing. This is a program that is not a requirement to install our batteries. It is an added benefit for those that are already installing our batteries. So it's important, if you're installing our batteries already, to get on this program so you don't fall behind. If you're an installer, you get on this program, you end up on our where to buy map. Customers are surfing on our website looking at, hey, who's an installer in my area? You show up as a blip that has completed this program, and that's somebody that we are saying that we know has gone through this program and is able to install our batteries. So if you already got 2 installs, that's the main requirement of the program itself. Go ahead and fill out the application. It takes like 10 minutes. It's on our IQ page. It just go under training and you'll find the IQ application. Scroll down and fill it out. It takes about 10 minutes, super easy. You'll become part of the program. You'll also be highlighted, and that can include everything from some marketing we're going to be doing, some trainings we're going to be doing, talking about our IQ installers. Our newsletter, the first iteration has already gone out. And the highlighted new installers that are highlighted, as well as the installer of the month, are highlighted there. Distributors are going to push for this as well. It increases their sales as well. This does not mean that you can buy direct from us. I think that question's come up a few times. If you're an installer and you apply for this program, you're still buying through your distributor. It's just that you are recognized as somebody that we trust to install our batteries on our page. So again, if you're already installing our batteries, jump in, join this program. I mean, it's super easy. If you've already met the minimum requirements, pretty much the only thing left to do is apply, and a very short test that we administer that can be taken as many times as you need to pass, and you can communicate with us to get the knowledge you need. It's very easy if you just take your time. So go to this link, go to the qualification program, scroll down, you'll see where to apply for that program. If you have any questions on that, there'll be an email address at the very end of this presentation, and that will touch that'll be the email address you want to shoot an email to if you've got questions on where to find this or just general questions. Okay, so kind of to look at what we're doing here at Simplify and what we're really pushing for, regardless of what topic we're talking about is, we're accelerating the energy transition that's becoming more and more prominent, cutting away from things that cause CO2 emissions and greenhouse gases and climate change. We're reimagining the power grid. This is probably the most important thing I can think of right now. We've got failing infrastructure. We need to build a more resilient energy future, as well as a more current resilient energy or power grid. We're seeing failures. I mean, if you're in California and you're dealing with the power shutoffs, these are planned. And really looking at the economic value of it. So that's always going to be, cash rules everything a little bit, but making it viable on an economic scale, and it really already is. All right, I just want to thank everyone that has joined us. I'm going to pop that email right there. So if you have questions, you can shoot an email there. We're going to go ahead and open the Q&A. So any questions for this specific presentation, I'll pop open right now, and we will start answering those. First question, give me 1 second here. I'm going to stop my video because I got to look at the other screen. Will there be a recording of this seminar? Yep, we have been recording, and that'll go out automatically. Do you offer utility scale products? I hope we answered that okay during the presentation. We do offer utility scale, or excuse me, actually, utility scale, probably not. If you're talking like a megawatt or 2 megawatt hours, we could probably fit into that need. But if you're talking like 20, 15 to 20 megawatt hours utility scale, we kind of steer clear of that right now. Can the BMS also have a time delay after a threshold has been obtained before it opens the circuit? This would be desirable to prevent a system from going offline unnecessarily from a transient event, but pushes the limit on potential battery damage, of course. Yeah, so we do have a limit or a time delay. Hysteresis often called in our battery management system, both of them. That is something we control. It's not controlled by the customer. Typically, we'll put our cutout a little bit lower than, as far as voltage goes, than you would have on your system. So the idea being that if you're programmed correctly, and again, if you're using an amplifier, it's automatically programmed for you, the system itself will cut before the battery management system internally cuts. If you're seeing battery management system cutouts, so the battery itself is actually cutting out, you need to assess your programming. Probably something's wrong on the inverter programming itself. And check out the low battery cutout delay programming on the inverter. Matt, did you want to add anything to that?
No, not really. I mean, I think that the time delay is more common on the digital BMS than the
Agreed.
analog. Would you agree with that?
Yeah, agreed. Next question: are you using high voltage contactors for your units? I'm guessing you're talking about our high voltage battery, and yeah, there's a contactor built in there to the switch gear. Have you used or have a need for lithium battery terminals? Matt, do you know what we're talking about there? I don't know.
No, I'm kind of confused here.
Sorry, Mike, I'm not sure exactly what you're talking about regarding lithium battery terminals. Okay, it looks like just a plug here for possibly some some equipment. Don't ask us. We're not going to be the right ones to talk to. I'd call our you can get a hold of our manufacturing if you've got any products that you want to integrate. When would you expect to have the Amplify battery communications with these Schneider XWs? It's on the list. I know it's getting pretty close. I won't speak to the exact time frame because I probably will screw it up. I believe SMA is the very next one, the Sunny Island, but there will be more to come. So just check back with us in a month or so and see where we're at. When I inquired about an Amplify 3.8 for an Outback Flex Power 2, one of your techs said it could be a year or longer. Do you have info on the next generation? Outback inverters coming down the line to replace the FXR. Are you going to do an Amplify version for the Radian? That's actually up in the air. I'm not sure where we're at with the Outback equipment. I know with Skybox, it'd probably be the Focus. If I had to say one was going to be the Focus. So I would definitely just stick with our standard Phi product in that case right now when it comes to those.
Yeah, and do we have info about the next gen Outback inverter? I would say, ask Outback.
Yeah, sorry.
We are not sure. But I could take the next question from Rob if you don't mind. He's sounds kind of like a tech support inquiry, but I actually think it's a great example here. He's got 3 batteries in parallel, and his solar charge controller is outputting full current at first, and then as the batteries charge further, he sometimes sees the charging stop before the charge controller enters float setting. What exactly is the BMS doing in this situation? So again, think of the BMS like the lifeguard. It's only going to open and close the circuit. It's not going to modify the power. It's not going to limit the voltage or the current provided by the charge controller. So if your battery is not reaching the absorb stage, you want to check on your settings in your charge controller and check and make sure you have adequate PV power incoming. Again, it's like the lifeguard. Right? If you're swimming outside of the bounds of the pool, he's just going to tell you to get out. He's not going to tell you to swim a certain way. Same with the BMS, not going to modify the power, just going to open or close the circuit.
Yeah, and that's always something important to consider is when it comes to our standard Phi products, not the Amplify. Oftentimes people say, well, what's going on with the BMS? Is the BMS doing something here? The BMS is internal. It is not altering your charge rate or anything like that. So it's got to be the equipment. Do you have any microgrid installations whereby the microgrid controller takes over the BMS programming? I'm not honestly 100% sure. Maybe. So the microgrid, I had to look at the microgrid controller you're talking about, but it is possible. I think it would more though work with the BMS in parallel, if I had to guess. I'm not a super big expert when it comes to our high voltage though. When adding additional amplified units to an existing set, what are the steps required as far as fully charging each unit prior to commissioning new larger set? Okay, so I'll talk in general terms for both the Amplify and the Phi products. If you are adding new batteries to existing batteries, as far as a kind of a consensus here, well, when it comes to the Amplify, the big only difference is that you want to make sure the firmwares are all updated on all the batteries. So if you're buying brand new batteries, you want to make sure that the older batteries have the most recent firmware on its battery management system. If you're buying your standard PHY, doesn't need that. It's not required. And then as far as charging goes, what I always recommend is just charge up. So the original bank, let it run through its entire charge cycle. And that just means let it do its charge cycle, let it go through, bulk, absorb, float if it's needed, and then disconnect that bank. Reprogram, so you're not going to overcharge the current or the new batteries. Charge those up, again, full charge cycle, let them go through there, and then just mix the batteries together. Now they've both gone through a charge cycle, they can mix and they can start to discharge and even out. We've got a lot of documentation on it though, so I won't bore you too much there, but there is a lot of documents that we have regarding adding batteries. I think this one is for you if you want to take this. This is a follow-up to what you just answered.
Yeah, give me just 1 second here. So, Rob, I would encourage you to email our tech support at simplifypower.com. If your batteries aren't reaching 56 volts during a charge cycle, if they're stopping at 54.6, like you were saying, I don't think they're reaching the absorb stage, and I don't think they're full completely. So I think that we should double check on your settings. The BMS is not going to stop the charge controller from providing them power. So let's go through those settings together. Just double check everything, and then
I would make sure compensation is not on.
That's a good point. A really good point.
Because that is not required in a battery and will curtail the charge.
Right.
So if it's with, I've seen a few Outbacks that were doing that. Just make sure to update all the firmware and everything as well. Last question I see here. What is the current protocol for absorb time and flow voltage, if any? So 56.0 volts at 6 minutes is absorb voltage and time. That is the most up-to-date setting. Float voltage, which I would only use if it's a DC charging source, so PV, wind coming from a charge controller, basically. 54.0 volts is the float voltage. Though if we're using an inverter charger, so we're charging from a generator, from the grid, or an AC coupled system, do 2-stage and no float. All right. Well, looks like we're out of questions. If anything else comes up, shoot an email. Go ahead and just shoot us an email at training@simplifypower.com. We're happy to answer any questions there. I really want to say thank you everyone that's joined. We appreciate it. I hope you enjoyed. And Matt, I'll appreciate you leading the charge there on what BMSs are and what they do. I learned a lot.
Same here. Had a good time.
Awesome. Thank you, everyone.